Hello everyone. So this is the setup for heat pump experiment, and in this video we are going to look into the process and identification of different components of this heat pump setup here. This is part one of the three parts that will follow for this heat pump experiment. Now first we look at this black color component, which is referred as compressor. Right side here, red bucket filled with water and coil dip inside. This region is known as condenser, and then you have the expansion valve, or sometimes referred as throttling valve. And then you have the fourth major component, which is the green bucket filled with water and a coil inside. This is referred as evaporator. So these are the four major components that make up the heat pump system. And these four, as you know from your theoretical courses, you have learned about air conditioning system, you have learned about refrigeration system. So it is the same setup that can be used for refrigeration and air conditioning purposes. The objective will change with air conditioning and refrigeration system. We are interested in trying to cool something, but here with the help of as a heat pump, we are trying to heat something, either water or air. Now with these four major parts identified, let's look at the miscellaneous components here. There is a pressure gauge, and black color here is a filter for filtering the refrigerant that goes in these tubes. There is another pressure gauge here. So the evaporator pressure measured with this gauge, condenser pressure measured with this gauge. So two gauges to measure the pressure. You have high pressure on this side and low pressure on the other side. Now all of these four components are connected to each other by means of these tubes. Okay, and then it is like a coil inside, and then comes out as a tube, goes through the expansion valve, then as a coil inside this evaporator region, and then comes out into the compressor. So let's look at the process now. Freon, or more specifically it is refrigerant 134A that is used with this setup here. So refrigerant 134A enters the compressor, gets compressed to high temperature, high pressure, and the high temperature, high pressure refrigerant travels through these tubes and moves in this coil. And since it is hot, it will heat the surrounding fluid. Hence the name of this coil is heating coil. Then after losing heat to the surrounding fluid, which is water, the refrigerant travels in this tube further into the expansion valve, where there is drop in pressure, and due to which there is a drop in temperature as well, and it is very, very cool after coming out of the expansion process here, and it goes in this coil in the evaporator section. And since the freon is very, very cool here, usually it is in negative temperature, something like -20, -25, it is able to cool the surrounding fluid. So it will cool the water which is around these coils. Hence the name of this coil is also cooling coil. Then it travels further after the cooling process, goes back into the compressor, compressed to high temperature, high pressure, after which it follows in this condenser, then expansion valve, then evaporator, back to the compressor. So it is like a loop. It goes round and round in a cyclic manner. So this is a thermodynamic cycle. It's a thermodynamic system operating on a thermodynamic cycle. Right, there are temperature sensors dipped in these. The black color one sensor dipped in here and another black color dipped in here to measure the temperature of water in the condenser bucket and the evaporator bucket, and these sensors can be read. The values can be read on this display here that comes in from the company Leibold, and the compressor power can be measured with the help of this joule meter, joule and watt meter. So these are the data collection tools available with this setup. Okay, so that is all about the description of the machine, the process and the parts. Like I said, we are trying to heat something when we are using this as a heat pump. So this is the area where we have the heating effect. We want to heat this water. If we were using it as a refrigeration or air conditioning system, we would be interested in this side where you have cooling effect. Now here water is being cooled, but in case of refrigerator you have to of course remove this bucket of water, and you have to make a chamber, and the air around it will get cooled. So that will be for refrigeration purpose. For air conditioning, again you have to remove this bucket, and then instead of that you have to put a fan behind it, and when the fan blows air over this coil, air will be cooled and you get cool air as the output from these coils. So so the same system can be used either for cooling application or for heating application. So depends based on what application you have, you can focus on one of these two coils. Both of them in general are referred as heat exchangers. This evaporator section is a heat exchanger, condenser section is again another heat exchanger, but the effect is different in both of these regions. In the evaporator region you have a cooling effect. Cooling is done to the surrounding fluid, and in the condenser region you have heating effect. Heating is done to the surrounding fluid. Okay, so that is all about this heat pump setup, and see you in the next part 2, where we look into data collection.